can if you want to. I'll record the entire thing and I'll send it to you guys. Okay, so this is asking for all of you guys' permission. Read the report. I hope everyone agrees. All right, the recorder has started. So today we'll be talking about array sorting. I hope everyone can see my whiteboard. Okay. First of all, imagine there's an array. Say, 8, 2, 5, 7. Take another number. 3. Okay, so we have 6 numbers in an array. The indexes are 0, 1, 2, 3, and 4. What is a sorted form of this array? Well, when we say sorted, we could mean two things, either ascending order or descending order. By default, it's sent to ascending order. So if you want to sort an array, what would be their final output? If I say sorted in ascending order, something's wrong with that. Okay, the final output should be 2, then 3, 5, 8, then 7. This should be my final output. Now the question is, how can we go from here to here? If you think about it, how do we do it? First, we scan through the entire array. This is my given array. We scan through it, and we find the minimum number. We say, okay, there's 2. So I type 2, and then I go through it again. I find 3, then I go for 3. Then I go through it again, I go for 5. This is how we're doing it, right? But now the question is, how do we make the computer understand?
So the 7-8 right? The one you have written after sorting.
Oh, yeah.
So we will compare the all the integers and then we will put the smaller ones to the left side.
Yes, that's one way. Okay. Did everyone understand Ahmed's approach? We have to compare every integer. Thank you, Shagor, for pointing that out. So if we want to compare, let's say I'm going through the array. I have my index I starts from 0. And how can I compare it with another number? If my I is 0, let's say my array is A. So A0 equals to 8 at the very given time. So now I have to compare 8 with another number. But I'm already running in a loop. My I is already 0. If I want to compare with another index, it should be using another variable. Is that clear?
Yes, sir.
Okay. Let's say I want to compare with the immediate next number. Let's say I say j equals 1. So now I will be comparing these two numbers, right? Okay. If I do compare, and let's say I found that my A0 is greater than A1.
Sir, your screen is turned off, I think.
Uh, no, I think my screen is on.
We can't see your screen.
It paused by itself. I don't know why. Can you see it now?
Yes, sir.
Okay. So we're trying to compare two numbers within an array. That's why we're using two separate variables. And if I'm comparing the first two numbers, I would be saying I is equal to 0, and I took another variable, which is j is equal to 1. Now I'm comparing these two numbers. Let's say if my first number is greater than the second number, I will swap. Okay, this is my first iteration. What about my second iteration? I need to compare two numbers again. This time, if I change my I to 1, okay, let's not change my I, because I need my I to iterate through all the numbers in the array. Uh,
Changing to
yes, the idea here is I will use my I to go through the entire array, and I will use j to compare between the next two variables. That's the idea of bubble sort. I'm trying to implement bubble sort at this very moment. So if I increase j by 1, my j will be 2, right? But I still need to compare between still need to compare between 1 and the next element, which is a2, right? So if you look at the indexes, this is actually equal to j. And what should this be? J minus 1. Is that clear? Okay, let me just show you how bubble sort actually works first. then probably you'll understand better. What were my numbers? 8, 8, 2, 5, 7. 8, 2, 5, 7, and 3. So what bubble sort will do is look at two numbers. I'll give them indexes as well. Better understanding. What bubble sort will do is first look at these two numbers. If the first number is greater than the second number, then it will swap. Otherwise, it won't do anything. If it's not, then don't swap. So here we see the first number is greater than the second number. So I'll swap it. After checking the first two numbers, my array should be something like this. On my second iteration, what I will be doing is checking the second and the third number, which are index 1 and 2. Is the first number greater than the second number? If so, then I should swap. 8 is greater than 5, so I should swap. 8 greater than 5. Oops. After that, my 5 will come here and my 8 will go there. Does anyone have any questions so far?
No, sir.
Okay. So last time we checked index 1 and index 2. Now we'll be checking index 2 and index 3. These two numbers. Is index 2 greater than index 3? Is 8 greater than 7? 8 is greater than 7, so I'll swap again. So you get the idea, right? If it's greater, then I swap. If it's not, then I don't swap. After I swap these two numbers, it's going to be like this. And finally, I'm going to check the last two numbers. If it is, I'll swap it. Is 8 greater than 3? Yes, so I'll swap. 3 will be swapped with 8. This is my one cycle done within the array. Can anybody tell me what I have achieved with this cycle? We can clearly see the array is not completely sorted because 5 shouldn't be here.
So we have got the maximum number at the right side.
Yes. With every iteration, we get the maximum number. Why is that? Because when we find a maximum number, we're swapping it to the right. Notice my initial array. My maximum number was at the left side. My 8 was at the very first index. But when we compared two numbers, we saw that this was greater. We swapped it to the right. And we did the same thing for every iteration. We swapped it again and again and again and made sure that the maximum number will be at the end of the array. Now, if you recall, we are trying to sort an array in ascending order. That means from small to maximum. With every iteration in bubble sort, we are finding the maximum remaining number. So in my first iteration, I got the absolute maximum number, which is 8. Can anybody tell me on my second iteration, what will be my last two numbers in the array?
So 7 and 8.
7 and 8, sir.
Yes. I don't know the rest yet. We'll have to find out. But this is how bubble sort is designed to work. In every iteration, I will start finding the remaining maximum number. This is something I already found in the first iteration. This is what I'll find in the second iteration. On the third iteration, I'll find 5 here. On the fourth iteration, I'll find 3 here. And in the last iteration, I'll find 2 here. This is how bubble sort will work. Is that clear to everybody? Okay. Now let's go back to we were trying to uh, understand if we use two separate variables, how we can compare. Now I'm saying I'm keeping my I for the entire array, and my j should be the ones that compare between itself and the previous number. That's why I'll be using ar- array j and array j minus 1. If I compare these two values, won't that mean that I'm comparing two values just next to each other? Since I'm starting j with 1, starting j with 1, right? So technically 0 is my j minus 1. And my 1 is j. It seems to be working. This wouldn't work if I started j with 0, because in that case I would have to use j plus 1, because I would try to compare 0 and 1. Is everyone understanding the approach I'm trying to take?
Sir, could you repeat the explanation?
Okay. Since we'll be comparing values within a loop, we need variables, right? So in my using I, I'll be going through the entire array, and using j, I'll be comparing two values just next to each other. Because in bubble sort, that's what we're supposed to do. If you look at what we did just before, how we traced the bubble sort. First, we compare the first two numbers, then the second two numbers. If we get the first number is greater than the second number, we swap it. We keep doing this until we reach the end. And in the end, we find the maximum number for that particular iteration. In my first iteration, I should be finding the absolute maximum number. In my second iteration, I should be finding the second maximum number, which is 7. And on my third iteration, I should be finding 5, and so on. This is how my array will be sorted. Is that clear?
Yes, sir.
Okay. Is it clear why we're using two separate variables, I and j? Because you might be thinking that since I'm using j for comparing each number, I'm not actually using I, am I? For example, for 0, I'm using j minus 1, and for 1, I'm using j. So why do I actually need the I? Did that question arise your mind?
So we use I to so just to count the iteration, or just make the iteration the number for the number of iteration.
Yes. If you look at this particular time, this one, can you tell me, well, when will we achieve this? When j reaches maximum length or I reaches maximum? By maximum length, I mean array of length.
So can you repeat?
Okay. This particular phase, I'm asking when will we achieve this? If we have a loop where I is equal to 0, and within that loop, j is equal to 1, and in the second loop, I am comparing j minus 1 and j, these two values. If j minus 1 is greater than j, I'm swapping it, right? This is how I'm trying to go through. And then I'm increasing j by 1. This is my approach, right? So what I'm saying is, I'll be comparing two values right next to each other. So when I achieve this particular thing, that my maximum number is 8, and I've put it in my last index. So in this particular stage, is my I done or is my j done? The loop, which loop is completed?
Firstly, your J would be the maximum because it has to go through every single element of the array.
Yes, j goes through every single element of the array and reaches the end of the array. And this is how we found out that when it reaches the end, the maximum number should be at the end, right? So using j, we can find a maximum number of a particular iteration. But is this array completely sorted? It's not. We need to start comparing again from the very beginning. This is why we need I.
We
What
need to
j gives
tell,
me
we
is
need to
the
tell that
maximum.
J
Yes,
equal to I at the last, the, at the, at the end of the, not the end of the loop, before the end of the loop. Should we say uh, J equal to I?
j will not be equal to I, and I'll tell you why just in a minute. But first, when my j is done, what we found is that the maximum number should be on the right side. But now, I should start from the very beginning again because my array is not completely sorted from the beginning. And but should I be checking the last element again? Because this is already the maximum number. And in an ascending order sorted array, this should be the maximum number. So I don't need to check the very last index again.
So, well, if you check it again, it shouldn't matter either way.
It shouldn't, but that wouldn't be very efficient coding. If you're sure that something that I already figured out the maximum number, and if you check it in every iteration again and again, your program is going to be less faster.
Okay.
Isn't that right?
Yes, sir.
So on my next iteration, I should be checking from here to here. I should skip the 8. But now, question might arise, like how am I supposed to know exactly from where to where I should be checking? My a dot length is given.
So j হবে স্যার লেন্থ মাইনাস I এরকম কিছু।
Yes.
Yes, sir.
Let's try to figure it out. In my first I, I should be checking everything, right? My I was 0. On my second iteration, I is 1. And on that iteration, I already know the maximum number, so I don't need to check the final number again. And on my second iteration, I will be 2. And on that iteration, I already know my last 2 maximum numbers. I don't need to check the last 2 numbers again. On my third iteration, I will be 3. I don't need to check last 3 numbers again. So that means if I put a case condition as a dot length minus I, that means I'm skipping the last I times numbers. Because on my first iteration, I was 0. I had to check everything. On my second iteration here, I was 1. I didn't have to check the last number, the last 1 number. On my When my I is 2, I didn't have to check last 2 numbers. When my I is 3, I didn't have to check last 3 numbers. So that means if I run a loop, start j from 1 and check and check 2 array length minus I, that should give me the right answer. Is that clear? If anyone
Yes,
has
sir.
any confusion so far, please ask me questions. Or you can write stuff on the chat. Okay, somebody asked me what happens if 2 numbers are the same. I don't need to swap it. Because my goal is to find the maximum number at the right, at each iteration. Let's say if there were 2 8s, would it matter if I swapped? Let's say there were 2 5s, would it matter if I swapped? In the end, my first iteration should be my maximum number reaching at the absolute right. On my second iteration, the second maximum should be reaching the absolute right. On my third iteration, this probably will remain the same. So it still goes like this. My final output should be 15588. So if it's the same number, I don't need to swap because it wouldn't really make a difference. What will happen if I swap 5 with 5? Nothing. However, if it's 5 with 8, then I have to decide if I want to swap or not. If it was 8 and 5, I would have swapped. Is that clear? Okay, so to sum it up a little bit, what we found out is we need 2 loops. This is where we came to the concept of nested loops. We'll be needing 1 loop that will start I equals 0, I less than a dot length,
Sir, could
assuming,
you please repeat the A dot length part again?
okay, the a dot length gives you the length of an array. For example, if this is your array, it has indexes of 0, 1, 2, 3, and 4. What is the length of the array? It has 5 numbers, so the length is 5. The indexes are 0 to 4. So if this array is called A, when I write A dot length, I'll be getting 5. If the array had 6 numbers, I'll be getting 6. If the array had 100 numbers, I'd be getting 100. So writing array.length, or in this particular case, writing 5 is the same thing. But writing numbers manually on your code is not always efficient because the array size can matter. Let's say I was taking numbers from the user. This might not have been my exact array. So in many cases, I will not know the exact length of my array. So it's safer to use array.length. I hope that's clear. I plus plus. Any questions? I think somebody turned on their microphone. I can hear some clicking. Okay, if no questions, then tell me this. Somebody wrote something in the chat. Any questions?
Sir, in the first array, our array is not totally sorted. We only got the maximum number to the right. But uh, if we need to like sort the three in the increasing order, then uh, do we need to keep on swapping them until we get it?
Yes, that was the entire idea. In my first iteration, I'm going to find the absolute maximum number, and I'll be sorting it. I'll be putting it at the end of the array. On my second iteration, I'll be finding the second absolute maximum number. On my third iteration, I'll be finding the third absolute number, maximum number. This is why I need two loops, because if I only run j, it'll only give me one maximum number. But I need to find maximum numbers on every index.
Sir,
That's the
your screen has turned off again.
why is that? Someone else has shared their screen. GS Onti, you can stop it. Yeah. Is it? Can you see me now? Can you see my screen now?
Yes, sir.
I'm guessing this is the first time you guys used Google Meet. Actually, I used it last night, my first time. We're all pretty new to this, but I think it's very convenient. You get to do classes while we're at home. I'm enjoying it so far. I hope you are as well. Okay, so do you see the problem? If we only use j, we get the maximum number of that particular iteration. So when I is equal to 0, we get the last maximum number. When I is equal to 1, we get the second last maximum number. When I is equal to 2, we get the third maximum number. So that is why we need to run the loop from I0 to a dot length. So we can get maximum numbers for every index. How are we getting the maximum numbers? By comparing with j. Is it clear now? Any confusions? You can ask me, but remember,
No, sir, no.
here's something you can turn off your video if you want. Well, Purja, you can turn off your video if you want. I'm letting better than Skype. Yeah, I would say so. Skype doesn't allow you to talk with 25 people at a time, I think. I think it has a limitation of 10 people. Okay, since we're done with this, let's go back to the loop. Okay, so now we'll be trying to sort within the array. By within the array, I mean two numbers right next to each other. Like previously, if I start my j with 1 and say j is less than, how long should I be comparing? We figured that out over here.
The a dot length minus I.
Yes. Is this word clear to everybody? Why is it a dot length minus I? Why didn't we calculate all the way to a dot length?
So because of efficiency, we don't want the code to loop up to n number because we know that for certainty, the n number is maximum number.
Yes. When my I is 0, I will be actually calculating a dot length because a dot length minus 0 is actually a dot length. But when my I is 1, that means my maximum number is at the very end. So I don't need to calculate that again. I already know, I already found a maximum number and I put it at the very end of the array. So I can skip that number particularly. Similarly, when my I is equal to 2, I know that the last two numbers are sorted. I don't need to take them again. That's why if we use a dot length minus I, that will give us exactly how many numbers I actually need to compare. I have this clear. So what should I put here? J should be less than a dot length minus I. Low battery area. Oh, my pen is almost out of battery. That's why it's okay, I'm almost done anyway. J plus plus. So in this loop, what should I be doing? I should be comparing two indexes, and if my first number is greater than the second number, I should be swapping, right? So if I say if a, I started j with 1, I can use j minus that 0, j minus 1, okay. We're doing bubble sort, Tanvir. What is the difference between bubble sort? These are two different approaches. Right now we're doing bubble sort. Next we'll look at selection sort. I think then you'll understand what is the difference between them. But in the end, they give us the same result. They should give us a sorted array. To be more precise, ascending ordered sorted array. That means from small to maximum numbers. in an array. Okay, I'm not. Let's not write the entire code. Actually, I was almost done. But I want you guys to do it. How can we swap two numbers? Somebody write it on the chat. How can swap two numbers? Well, it may vary from person to person. Bubble sort may be easier to some people. Selection sort may be easier to some people. That's why we have different algorithms, so people can choose between them. Some people might prefer bubble sort. Some people might prefer a selection sort. There are actually a lot more sorting algorithms, but we won't be covering anymore in this course. So my question was, if I want to swap between a j minus 1 and a j, what would be my code? I will be reviewing selection sort right after this. Don't worry.
So we will store our first variable to another variable, and then we will swap these two, and then we will store the other variable to the first place.
Yes. Yes. So we need another temporary variable, because if we write directly, if we say, let's say I want to swap, so we might be thinking, let's just put it like this: aj and aj should be equal to aj minus 1. But there's a problem with this. Initially, what was my array? I think the first two numbers were 8 and 2, right? So this is 8 and this is 2. So after this line, both will be 2, because in computer science, what did we learn? When we assign a value, this particular value gets assigned on the left side. So this is like 2. The value of this side is 2, and when it gets assigned to the right side, it'll be 2 as well. So if I do this, both will be 2, and in the process, I'll be losing my 8, which was previously here. And on the second line, if I again, this is now actually 2, and I'm assigning 2 again, so this will be 2. You see the problem? Everything will be 2. Where's my 8? I was supposed to swap between the numbers. This is why we need another variable to store that 8, so it doesn't get lost. Let's go to int temp. I'm naming this temp because this is a temporary variable. I'm probably not going to use it anywhere else in the code. You can name it anything you want. So I want to store the 8, right? aj minus 1. Now, my temp stores 8. This will still be, after this line, both will still be 2. But now, I need to assign aj as 8, right? So where's my 8? I stored it in my temporary variable. So this should change, and I should use temp. This way, I've completed my swapping. Is that clear, everybody?
Yes, sir.
Okay. So now, what will happen when J is increased by 1? Someone asked me a question. Should I be, instead of J minus 1, should I be using I? I said, no, I shouldn't be using I, and I'll tell you later. So if you look at it now, when my J increases by 1, then this will be 1, this will be 1 minus, I'm sorry, this will be 2, because J started with 1. J started with 1, this is my first iteration, 8 and 2, swapped, and now J was increased by 1, so J is 2, and J minus 1 will be now 1. And my second iteration, J will be 3, J minus 1 will be 2. But if you notice, my I is not changing at all. My I is still 0 because I'm still in the nested loop. I'm still inside the second loop. When I leave the second loop, when my J finally reaches this particular array dot length minus I, then I will finish my nested loop. Then I will increase by 1. Did you get your answer? Why I didn't put I and use J minus 1?
Would you please explain the swap section, please?
Am I going too fast? If you have any questions or confusions, anything.
Sorry, I'm not getting the thing how we are using the I.
Okay, let's go back a little bit. This was my initial array. I'm checking two numbers. If if the first number is greater than the second number, I'll swap. I'll be doing this until I reach the end of the array. So with this, I've completed actually only my J from start to finish. This is my inner loop, one inner loop done. If I go back to the code, what I've completed so far is just this loop. So after every J loop, I'm getting the maximum value at the right. So is that enough? I mean, after completing one loop, which is J, I'm talking about the inner loop, I'll be getting one maximum number. But my array is not completely sorted. I need to find the maximum number between these remaining numbers as well. I need to find 7, I need to find 5, I need to find 3. So to find those numbers, I need to keep track of another loop, which is my I. That's why I need nested loops in this particular case. One loop is not cutting it. One loop will give me one maximum number, but one loop inside another loop will give me maximum numbers every time that loop runs. And how many times is that loop running? Array.length, I. So if I use an outer loop and keep track of all the numbers, I starts from 0 and I goes to array.length. Then I can ensure that I'm finding the maximum number in each J loop. So when I'm finally leaving this loop, I'll be getting the array like that. Then when my I will be increased by 1, I won't be checking the last element again. That's why I wrote array.length minus I. So in the second iteration of I, if I complete the J loop, I'll be finding the second maximum number, which is 7. Is that clear now?
Yes, sir.
Even if you still have confusions, you can always ask. I don't want you to, to say yes, sir, because you don't want to feel embarrassed or anything. I want you to understand everything. I hope you did understand. But even if you do have confusions, it's okay. You can ask again. I'll explain again.
No, sir. It's clear to me now.
All right. Did anyone ask any other questions? Yes, I'll. Okay. The swap section again. Okay. Right now, I'm trying to check if the first number is greater than the second number. If it is, then I'll swap. But if I try to swap without taking a temporary variable like this, the problem is I'll be losing a number. For example, they are right here. If my a j minus 1 is equal to 8 and a j equals to 2, if I try to swap it like this, a j minus 1 equals a j and a j equals a j minus 1. Yes, I'm doing exactly that. The problem with this approach is
Here, temp create a temperature memory that to the
I couldn't hear you. Could you say again?
so here temp create a
Yes.
temperature memory where it put AJ,
Yes, we need to
right?
store temporary variable, but I'm showing if we don't, then what difficulties we might face. Since a few students have confusion over this topic. So my currently
Yes, sir.
AJ is 8 and sorry, AJ minus 1 is 8 and AJ is 2. But after executing this line, this 2 will be stored in AJ minus 1. So both after this line, both will be 2. I didn't keep my 8 anywhere. And after, if I execute the next line, uh, this is 2. This is already 2, and I'm assigning 2 with 2 again, so both will be 2 again. In the process, I lost my 8. There's no way to get back my 8. So if I store my 8 somewhere before swapping, like a temporary variable, aj minus 1, then my 8 remains in temp. And when I execute this line, both will be 2, and that's fine. because I still have my 8. So instead of writing aj minus 1, I need to store my 8 in aj now. Where did I keep my 8? In my temporary variable. Now, temp equals to 8, and 8 will be stored in aj. So in the end, what am I getting? aj minus 1 right here. This will be 8, and this will be 2. So I've successfully swapped. Have this there. Does anyone still have any confusion regarding the swap? This is what I actually did in my code. I kept my aj minus 1 somewhere as a temporary variable. Then I put my aj's value in my aj minus 1. So technically my 8 was replaced, but I have it stored in my temporary variable, so it's not completely lost. And then I replaced aj with the temporary variable. Okay, if we understand the logic so far, let's try to implement bubble sort. Okay, this may be a little new to you. This is called an IDE. We so far we use Dr. Java in our labs and in our theories, but this is my personal PC and I don't have Dr. Java here. If you do go to advanced courses of CSE, I'm not sure you need to because you guys are probably not in the CSE department. You guys are triple E and ECE people.
So is this NetBeans or something?
Yes, this is NetBeans.
Hmm.
And there are a lot of advantages using IDEs over tools like Dr. Java. For example, let's say I initialize an array. What were my numbers? I forgot. It's okay if I take random numbers. I'll say 5, 1, 7. Okay. We saw in the previous class that this is how we can define arrays. You see, there's already a red mark given. It's saying array initializer not allowed. Anybody tell me why it gave me this? We didn't write the main method. So these are some advantages. When you use an IDE, when you code, it gives you responses. It gives you warning. You don't have to compile it. Okay. And do you see I press B and it's already expecting, but do you want to write void? Yes, I do. I'll be setting void main. Main. Even showing me that this is my main method. All right, now if I put, it's still going to say an error because I accidentally didn't put the array symbol. Now it's not showing me any errors. It's fine. It's giving me an underline. If I hover, it's saying A is never used. It's true. I haven't used it yet. Okay. So in bubble sort, I need 2 loops. That's what I figured out just now. I'll use a for loop. Int I equals 0. I less than A Notice I'm also getting suggestions. If I say dot, it already shows me all the methods A contains, and I see there's a method called that. Not a method, it's a property. We'll discuss methods and properties and classes in the upcoming classes. And I'll need another loop. J should start J from 1 because I'll be using J minus 1 to compare the previous number. If I start J with 0, J minus 1 would give me a negative number, which will result in an error. If you do start with J equals 0, you have to make sure you compare the next number, J plus 1. J is less than A dot length minus I, J plus 1. Now I have to check if my J minus 1 and J, if my J minus 1 is greater than J. So I need an if condition. A, J minus 1 greater than AJ. If it is, then it is so. Confirming variable equals A, J minus 1, A, J minus 1, okay. AJ So that's it. That's how you sort an array. Isn't that simple? Just a few lines of code. It doesn't matter how long the array is. It doesn't matter how many inputs the user gives. This will work for everything. It's clear why somebody asked before that since we're using an array, we get to access every number. Why do we need sorting? Why don't we do it manually? I hope you got your answer now. All right. To verify if our sort worked, let's print out the array. We print out an array.
Sir, I have a question.
Yes, please ask.
So the materials you have provided in the sample code, they used another method called bubble sort. So we don't need to use that. We can.
No, you can choose.
I think.
All right, now let's try and run it. This is my given array, 82517. My sorted array should print 12578. Let's see what it prints. See the output right here, 12578. Let's exchange a few numbers, check if this works. Let's turn this into a 0. 01257. Let's turn something into a negative number. Okay, this is minus 10257. All right, so our bubble sort seems to be working correctly. Any confusion regarding bubble sort? If not, I'll be moving on to selection sort. now if I say um, instead of a fixed array, take input from the user and put it inside an array, then sort it, can we do it? Yeah, can we do it?
Yes, sir. We have to use a loop and then initialize every element that the user gets.
Yes. We have to ask the user how many numbers do you want to input. We have to initialize an array. We have to use the loop first to take the numbers and fill up the. Then is the same thing again. These- Basically, these things, this particular thing sorts the array. This particular thing, I'll comment. I'll write a comment here. Sort array using bubble sort. This is print the array. When you write long codes, it's better to write comments so you understand exactly what purpose this particular portion of the code serves. Because if we implement selection sort as well in this particular code, and later, let's say 2 days later, I look at my code, I may get confused. Like, why did I take a loop? Why did I take a second loop? What's going on? And what's this loop for? This was a fairly simple problem, so writing comments wasn't that necessary, but it's for good practice. It's not mandatory, but as programmers, we tend to get lost when we write a lot of code. So it's good practice if you write comments, just just for your own benefit. Okay, let's go to selection sort. I think I can erase all this now. Where's my pen? Still has battery. Selection sort. This is another sorting algorithm which gives you the same result, but it takes a different approach. In bubble sort, we compare two variables next to each other. In selection sort, it's a bit different. Let's say this is my array. Are we going through? Okay. First, let's go back to how we're solving it. If I say that sort this array right now, first, what do we do? What do we do? We go through the array. We see, oh, 2. That's probably the minimum number. Let's see if there's a smaller number than 2. 9, 5, 3. No, the 2 is my smallest number. Okay. Then I have to take my second smallest number, which is 3. Then 8, 9, and 5. These are the remaining. 5 is the smallest. Then 8, and lastly 9. This is how we humans would try to sort the array. Selection sort takes a very similar approach. it finds the minimum number of the entire array and swaps it with the first element. I'll say it again. It goes through the entire array, finds the minimum number, swaps it with the first index, which is A0. That way, in every iteration, what do you get? The first element is sorted. In the second iteration, the first two elements are sorted. In the third iteration, first three elements are sorted, and up to array.length. That's the entire idea. So how does this work? Let me show you a few iterations. In my first iteration, I'll be needing a variable to store which is the minimum number. So I go from index 0 first. My first number should be initialized as my minimum number. Remember, we used this concept when we tried to figure out minimum and maximum numbers within an array or within a list of numbers. We took our first number as the sum, as the average, as the minimum, as the maximum, because that's all we had. So in my first iteration, I0, I'll write that down as well, I0. My minimum at this very time is 8, because that's all I have. So when my I is increased to 1, I check if my previous value, I check if my minimum, my AI is less than my minimum. My AI is currently 2. 2 is less than minimum. Then I update my min. Then min should equal to I. This should be in an if. This should be the code. Then my I is increased to 2. So currently my minimum is 2. I check if my AI is less than min. My A2 is 9. It's not less than min. So I shouldn't be going inside this if. So my minimum remains 2. Then my I is increased to 3. So I check if 5 is less than 2. It's not. So my minimum remains the same. Finally, when my I is 4, I check if 3 is less than 2. It's not. So my minimum remains the same. So after my first loop, I will be swapping my swap AI with the minimum number. Now, what does that mean? That means in my first iteration, I should be swapping this with this. This should be here, and this should be here. Okay, so after my first iteration, let's draw the array again. Nine, five, three. Okay, since we're comparing values again, we will be needing another nested loop, just like before, because in my I, okay, let's do the second iteration first, then you'll understand. In my second iteration, I should be starting from here, right? And check the minimum number again. First, I check First, I put min to 8, then take the first element, take the second one is 9 greater than 9 less than 8 is not, it remains the same. Is 5 less than 8 is not, remains the same. And finally, 3 is less than 8, it is, so it gets updated to my ministry, and then I'll have to swap between these two numbers. My 3 will go to index 1, and my 8 will go to index 4. So after my second iteration, it's going to be like this. This will remain the same. Here. Similarly, I'll be checking within this part now. If I find the minimum, it'll be swapped with this number. On the next iteration, I'll look between these two numbers. The minimum will be swapped in this particular index. Is the idea clear? So in the end, what's going to happen? I keep swapping it with the minimum number, and finally, I'm going to get a sorted array. In my third iteration, okay, let's just do it. In my third iteration, my 5 will be swapped with 9. It's going to look something like this. 3, 5, 9, and 8. And on my last iteration, I'm going to swap these two. On my final step, it's going to look something like this. Is the idea clear to everybody? Collection sort, how it works? In bubble sort, we compared two numbers right next to each other, and we made sure the maximum numbers remained at the very end of the array. In this particular case, we're going through the entire array, we're finding the minimum, we're replacing it with the first index, and then we're going through the entire remaining array, we're finding the second minimum and replacing it with the second index, and so on. These are the difference between the two of them. Okay, you want me to repeat the whole thing? I think it'd be better if you could tell me a certain point you didn't understand. Fahad left. What, is it getting too hard? I can't take it anymore. Guys, it's not that difficult. Let's go through it again. The idea is to go through the entire array, find the absolute minimum, and put it in the first index. Then go to the remaining array, find the minimum, put it in the second index. Go to the remaining array, find the minimum, put it in the third index. This is how we're sorting the array. If we look back a little bit, in the first iteration, we went through the entire array. Right here, we found the minimum was 2. So we put 2 in index 0. And the remaining array, we found this is the remaining array. We found the minimum was 3. Where is 3 located? It's in index 4. So So we replaced index 4 with index 1. When we did that, we got this 0, 1, 2, 3, 4. And then we looked at from 2 to 4. What's the minimum number? It's 5. So 5 should be in index 2. That's how we got this one 0, 1, 2, 3, 4. And lastly, my remaining array was between 3 and 4. We looked at it. What's the minimum number? 8. We put it in index 3. 0, 1. And our array is sorted. Shagor, is that clear? Or do you want me to go through it again?
So could
I
you
guess.
give a different example, like the code for the selection sort?
Okay. Why don't you help me out? What do you think? What can I use? We can say that we need at least one loop to go through the entire array.
Right.
Yeah.
Right.
So we're going to the entire array, a.length.
I plus plus.
Okay, so what did we need to do? We need to keep track of a variable called min, because we want to store the min somewhere.
Right.
Because so let's keep a variable in min. Initially, let's put it to the first value, which is my I, because I is starting from 0, right?
Right.
So currently my min would be equal to 8. Okay. After that, we need to check. We need to go through the entire array and find which one is the smallest. Which one is exactly the smallest? Because up till so far, I only have one element, which is my index 0. Is that clear?
Right.
So if we need to compare again with this particular index, we need another loop. We need to go through the entire array. Let's use j. Where should I start j from? I'm using j to find out the minimum number of the remaining array. Let's start from 0.
Sure.
Let's see what happens. Because I started I from 0. Let's see what happens, okay? J less than a.length, because I do need to check.
-1.
If you say -1, it's going to leave out the last. That was valid for bubble sort because I was finding the maximum and putting it at the very end. But in selection sort, am I finding the maximum and putting it at the end? No, I'm trying to figure out the minimum and put it in the front.
Right.
So if I start j from 0, I should be checking all the elements. I should be giving out the first element, to be more precise. But that's why I shouldn't be starting j with 0. I should be starting j with I. Because I is increasing in every iteration. I is first 0, then I will be 1, then I will be 2. When I is 1, I don't want to check the 0 again, because I know 0 is sorted. You see the idea? Are you confused? Where did you leave to?
Yeah, it's all right.
Okay. So then I should increase j by 1. The purpose of j is to find the minimum of the remaining array. So I need on the if condition. If aj is less than the minimum number. Now, there's the problem. Up till now, we know what the minimum number is using using int min, right? But do we know the index?
No.
That's why we need to keep another variable to keep index. Min index. You'll see later that we don't actually need to keep track of min at all. If we only have the index, we have the value as well. So actually, it's more efficient to just keep the index. But for better understanding, I'm keeping min. So my main index, initially, I've set it to I, because that's all we have right now. So if main index, then I should be doing the swap. Swap from which to which? Actually, I shouldn't be swapping here. If I find a minimum number, do I swap right away? What was our... When I find a minimum number, I update my min value. And I'm checking all the numbers. Then the min value I have, then I swap it with the first index. And that was my approach. So swapping shouldn't occur right just yet. If I do find a minimum number, I update my minimum. Min should equal to aj. Because I found that aj is smaller than my previous minimum number. Let's go back to the array. What happened here? First, we looked at 8. My min was 8. My aj was 8. Then when j increased by 1, my j is now 1. I checked with my minimum. I compared it with my minimum. That is this less than my previous minimum? Previous minimum was 8, and my current aj is 2. So 2 is less than 8. So I updated min to 2. This is exactly what I'm doing in my code. Then I have to increase my j again to verify the absolute minimum number, because there can be another number less than 2 in the remaining array. So I actually have to go through all the numbers, find the absolute minimum. When my entire iteration of j is done, I should be getting my minimum number in my minimum variable. The value should be stored there. That's why I'm using another loop for j, and I'm checking if my aj is less than my previous minimum index. If it is, then I update my minimum, and I should also update my minimum index. My minimum index should now be j. Sagar, is this clear?
Yes.
Now, so when do I actually swap? I swap when my j completes the loop. Because when j completes the loop, it means that it's done finding the minimum number for that iteration. Now, where should I swap the... Okay, after my j is complete, I should have my minimum number in my min variable and my minimum index in min index. So I have the value and the index number. Now I should swap it with my first number in my first iteration, right? Who's keeping track of that? We do have another variable I, which is going through the entire array again. So even though my j is complete, my I is still 0. So I should be swapping it with my I, because only then I will be increasing 1. Then I should be looking at this portion of the array. And since my j will start from I, it should check from 1 to array.length. Similarly, when my I is increased to 2, it will check from 2 to 2, 3, and 4. When my I is 3, it will only check 3 and 4. So when my j is done checking, then I have the minimum number, and then I swap it with my I index. This is the end of my j loop. So this is where I should swap minimum number with I. So similarly, I need another temporary variable. And done equals a min index. A min index equals AI. AI should equal to 10. This is the closing of my the outer loop. Okay, so this was the idea of selection sort. If you have any questions, you can ask now, or I'll move to coding. We'll try to implement it and verify if our algorithm works. Is everyone with? Is the lecture so boring people fell asleep or something? I have no way to verify. It has been a little lengthy. I do understand that. I'm taking 2 lectures in one, but we're almost done. I hope everyone is still with me. Somebody please respond or something.
Sorry, sir, but the selection sort is kind of tougher than the bubble sort. So we are trying to understand first, then we'll ask the questions. Sir.
Of course, sure. Do you want a break? Let's take a 10-minute break then.
Mm, sure, why not?
All right. So I need replies from a majority, because some other people might be taking other online classes and the times might clash. So if I take a break, if some other student has another, they should speak up right now. Then I won't take a break.
So I think if we can finish in 10 minutes or 20, then we don't need a break.
We're almost done actually.
Yes, sir. Almost, and we just
Then we should not take the break. Then we should continue.
All right, so yeah, let's finish it up, and I'll let you. After the class, you guys can go through it. The resources are in the Google Classroom. Watch the YouTube video again. I think it'll be much clearer this time. Let's try to implement the code. I already did, but let's do it together again. Second array again, and a equals I need two loops. This is before. And I equals 0. I is less than a dot length. And then the loop. Okay. You should start from I because after the first iteration, when I is not 0 and I is 1, we should be certain that index 0 is correctly placed with the smallest number. So I don't want to check index 0 again. If I is 1, I should start checking from 1 to array length. So that's why I'm dynamically calculating the value of j. It's dependent on I. Right? Okay. We need to keep track of the minimal number. Let's say int min equals a I. And I need to keep track of the index as well. Min index equals I. Because this is the index, right? Okay. Now I have to see if my AJ is less than my existing min. If I do that, I need if condition AJ less than a min index. Then I'm going to update my min should equal to AJ, and my min index should equal to J. That's it. That's why I needed J to find the remaining minimum value. So I'm now outside the second loop because now I need to swap int temp equals a minimum, storing the minimum index value to temporary variable. Now a min index need to swap it with AI. Oh, I made a mistake. It should be 10. And I'm storing my first min index into temp. Then I'm replacing my min index value with I, and then my I should store the value inside temp. Alright, so this is my selection sort done. Let's print. Okay, let's put comments again. Right. Okay. I'm in the print array. So I need to loop the print arrays. Okay. And then I'll print element. Up till after this for loop, it should be sorted, and then I'm printing it out. Okay. If I look at my array, my correct answer should be 1, 2, 4, 5, 7. Let's see if it gives me the right answer. 1, 2, 4, 5, 7. Let's see some values. Let's say I want this to be minus 2. That seems to be working perfectly. Now,
So what
if I
if
look at the code,
array has n numbers?
yes, you tell me. What if the array has n numbers?
N numbers instead of 4, 5, minus 2, 1, 7. What if it had any number, like n numbers?
Yes, then you will have to use a scanner to take n inputs from the user and then run the same code. This for loop goes from 0 to array.length, which is actually n, because the array has n numbers.
Yeah, there has n numbers. So the code remains the same.
Yes, only how you store the values in the array will change. But your sorting should remain the same because we didn't fix anything in this particular code. This goes for array.length. This checks every value. Let's change the length and find out. Okay.
Right.
This case still works. And it's still 0, 1, 4, 4, 5, 5, 7. Even if you have the same number over and over again, the sorting is still valid. Is it clear now? Cover? It doesn't matter what the array length is. It doesn't matter how many input the user
So
takes.
all I have to do is use a prompt and store the input first
Exactly.
from the user.
Yeah. Sorting algorithm stays the same. You just have to take numbers from the user and put it in the array.
And so in the question, will we be asked whether to use the bubble sort or the selection sort, or is it independent of whatever we use?
It might be predefined, but use bubble sort to sort these elements in the array. So you have to understand both.
Okay.
All right, my IntelliJ is giving me some warnings that my min is never used, is never reassigned. So if you think about it, do I actually need my min? If I only have the index, I can actually access my min at any point. Isn't it so? If I have I stored in my min index, I can always go for a min index to retrieve that min value. I took min as a variable, so we understand how selection sort actually works. If I remove my min and only keep track of my min index, isn't that enough? Let's verify. So give me -1, no sorry, -2, 0, 1, 4, 4, 5, 6, 7. You know what? Let's add a few numbers more. Let's give 9. Let's give 3. 12 again minus 3. I'm not even storing min this time. I'm only storing the min index. It's giving me minus 3, minus 2, 0, 1, 3, 4, 4, 5, 5, 7, 9, 12. This still seems to be working fine. Because I don't actually need the min value. If I only have the index, I can access the value at any point of time, right? That's the concept of an array. But I am actually comparing the min value by using the min index within the array. So I don't need to store min separately. I can only, if I only store the index, that's still efficient. That's more efficient. But if you do want to keep track of min, you can store it. Technically, it's not wrong, but you're wasting a little bit of resource. You're using a variable to store a certain value that you don't actually need. So anyway, don't think about it too much. If you're comfortable using min separately, use it. It's fine. When you finally understand the entire thing, then you'll realize that I don't need to keep track of min. Min index is enough. It'll come naturally. Don't worry. All right. So today, a lot of people already left. So today we covered bubble sort and selection sort. I hope you guys understand, or at least have a better idea about these things. And I would still suggest you to go through the resources I've set out for both selection sort and bubble sort. Just watch a few YouTube videos, go through the code again, tweak the code here and there. I'm sure you'll understand it better. Change the code according to your logic. See what happens. See where the errors are happening. See why it's not giving you the right result if you change the code. This is the best way to learn programming. Okay, so if anyone has any questions, you can ask, or I'll end the meeting right here. I'll stop the recording.